Okay, so let's review a little bit about how the objects of our search are distorting the Earth's magnetic field and giving us a response that our magnetometers can detect. One of the primary distortion methods is caused by induced magnetism. So the objects that we are looking for, whether that be a 55-gallon oil drum or some sort of steel components that fell off a rig or a tackle, some sort of a sunken ship. The primary mode of distortion is called induced field. And so the induced fields give us a fixed distortion based on mass and distance, a relationship that I characterized as inverse cube. But we found out also that most of these objects will eventually pick up a permanent magnetic field, which can increase the distortion or the size of the anomaly by a factor of 3 to 5 or more. So these objects become easier to locate. Now I want to talk about yet a third type of amplification that we get from the natural object itself. And this has to do with the fact that most objects that we are looking for are hollow. So let's say we are looking for a car that has been driven into a lake or an estuary, and the police are looking for the car. Well, perhaps the car weighs 1 ton. So we would expect to see 1 nanotesla at 100 feet. But parts of the car are hard steel, and they were formed in a foundry like the crankshaft and so forth. So there is permanent magnetic fields associated with the steel parts of the engine. And so this number may then become as much as 5 nanotesla at 100 feet. But there's another factor to consider, and that is that the car is somewhat hollow. So we have a car that has certain metal parts in it, but it also has certain metal skin which keeps the Earth's magnetic field from actually entering into the interior. So the Earth's magnetic field wants to come and go inside, but it can't because of the steel covering. And so the Earth's magnetic field tends to flow around the outside of the car, and because it is not entering the inside of the car, to the Earth's field, this amount of mass looks like it has much more interior metal. So the Earth's field cannot go inside. It thinks it's solid. And so we can get an amplification due to volume that is based essentially on what the anomaly would be if the mass were not the external volume, the actual weight of the material, but the enclosed volume. So a car may be a ton of steel, but if it was a solid steel car, it might be 5 times bigger. And so again, we might then be able to raise this 5 nanotesla up to perhaps 25 nanotesla, and this is due to the volume effect. So we see that even small items, if they're, for instance, like a shell, like an unexploded military shell, the interior is there's a space inside for explosives, and because of that, even though the shell may only weigh 30 or 40 pounds, it looks to the Earth's field as though it weighs 200 pounds, and therefore we get an amplification of this distortion, and this object becomes easier to find with high sensitivity, high speed magnetometers made by geometrics. Okay, so we have seen that we have induced magnetic field distortions of the Earth's magnetic field that give us the ability to see small objects at great distances with a total field magnetometer. The induced fields give us approximately 1 nanotesla of Earth's distortion at 100 feet for 1 ton. We learned that remnant fields can give us as much as a 5 times increase in field distortion, meaning that instead of seeing 1 nanotesla at 100 feet, we might see 5 nanotesla. Alternately, these multipliers that I'm talking about actually reduce the size of the targets that we can see. So we can see smaller and smaller targets. But remember, we need to get enough samples over them so that they don't look like just a spike. So we need, if we have an object, we need to get enough readings that they don't just look like a spike, or when we plot the data, it just looks like some sort of noise. So we need to get enough readings to be able to determine that in fact this is a real anomaly. And we know something about its position and its depth from the profile that we have plotted. So we saw that we could get as much as a 5 times increase in the remnant field. We also saw that we might be able to get up to a 3 times increase in the volume of the object if it's hollow, which is true of most unexploded ordnance, most ships, and other types of man-made artifacts, pipelines and so forth. There's one other amplifier, and it's called aspect ratio. And it has to do with the fact that if an object has an aspect inequality, for instance, let's say we're looking at something that has it's 6 times longer than it is in diameter. This is true of most ordnance. So this is true of most types of projectiles that fly through the air. Then this longer and thinner object will tend to bring the Earth's magnetic flux lines through it. And it will, even though the Earth's magnetic flux lines may be coming at some other angle, when you have a long aspect target, it actually tends to bring the Earth's magnetic flux lines through the ends, as in a north and south bar magnet. And so the induced fields are amplified, and we get some sort of an aspect ratio increase of the distortion due to that object. It could be 2 or 1. It really depends on those relative dimensions, and also the susceptibility and some other factors. But what we see here is that we could easily get a 30 times increase in distortion due to these amplifying factors. This means that we can see things that are essentially 30 times smaller than the basic rule of thumb would indicate. So what that really means is that, for instance, 250 pounds at 50 feet, we might easily be able to see something that's more in the 10 pounds. Simply because if it is in fact hollow, if it is in fact permanently magnetized, and if it is in fact longer compared to its dimension, to its diameter. So all of these things enable us to find objects, and all of them inform us about how wide our survey lines should be.